Okay. So we should know how to solve exponential equations. So now we're solving logarithmic equations. Okay. So you have to remember inverse properties. There was 2 of them. So one was if it's log base a of a to the x power. So you have same base in your exponent. Basically they cancel and you just get out the exponent. Okay, so we know that these cancel. Same we said if it's a to this lovely exponent that has a logarithm. So log base a of x. So whenever you have the same base with logarithms, they cancel each other out. You're just left with like that expression inside. So we're going to be using this second option today to get rid of a logarithm on both sides. So if we can, we should always try and use the one-to-one property. Which most people recognize one-to-one property, so if you have the same logarithm on both sides, they cancel each other out. Like I say, it's not really doing anything since it's on the same side or both sides. So you might have a couple like that you can solve. But for the most part, I'm going to say we're doing inverse properties today. So hopefully we remember how to use logarithms and work with them, because all the properties about logarithms are going to come back today. Okay, so we have the natural log of x equal to 2 thirds. Yeah, so we have to use e because that's the opposite of natural log. So whenever you have a logarithm, you want to raise it to an exponent. So now it's e, and everything from the above is in the exponent with e as your base. Okay, so then on the left side, e and natural log cancel, you just have the x value. If you want an exact answer, you could just leave it as e to the 2 thirds. If they ask for an approximation, you should figure out what this is in your calculator. So what is this to like the second decimal? $1.95? Okay. So depending on what they ask you to do, either one of these are acceptable. Okay. Next one. So this one reads log base 4 of 3x plus 2 equal to log base 4 of 6 minus x. So any ideas where to go with this? Right, so we're using the one property, so they just kind of cancel each other out since they're on the same side. So then we have 3x plus 2 and 6 minus x. And this is an equation we can just combine like terms and solve. So I would add x to both sides and subtract 2 to both sides. Yeah. So then x equals 1. Okay, next one. We have log base 3 of 5x plus 13 minus log base 3 of x for 6 and equal log base 3 of 3x. Okay. So this one we have the same logarithm for everything, which is nice. We have log base 3. On the left side, we have two logarithms. We should basically combine these together by using a logarithm property. So does anybody know how to rewrite a logarithm when it's being subtracted? Yeah, so subtraction changes to division. So we can write it with one logarithm, log base 3. But now the things inside the logarithm are fractions, so 5x plus 13, and then divided by 6. And the right side just stays the same because there was nothing else with it. Okay. So now what are you going to do? One-on-one property, so log base 3 cancels. How do you want to start solving this equation? Yeah. Multiply 6, what's in the denominator? To both sides. So left side of 6 cancel. So now I don't have that fraction to make it all weird. Yeah. So x equals what? You can always check it by plugging it back in if you want to. I just don't like to check with logarithms, but it is possible. Okay. So moving away from one-to-one property, basically, using more than inverse properties. I would like to solve this. So if we can, the goal is to try and get the logarithm by itself on one side and everything else on the right side. So we have like that 6 and 3 on the left side with logarithm. I want to move those over. So that way I can use an inverse property. So I can't use an inverse property until the logarithm is by itself. Yeah, subtract 6 first. Yeah. Divide by 3 on both sides. So the natural log of x equals negative 2/3. Yeah. So to get rid of a natural log, we take an e to both sides. And everything is in the exponent. So the left side is our one-to-one property where this cancels, and I just am left with x. On the right side, it says approximate to 3 decimal places, so we should type it in your calculator to get an approximation. Three decimals, so what's the next one? Okay. That's not too bad. Not really. Same thing like the last one. We want to try and get the logarithm by itself. Since we don't have logarithms on both sides to do the one-to-one property. So basically the 6x is going to stay with the logarithm, so I can't do anything with that. But the 3 in front, I can move on over. Yep. So we're going to divide 3 of both sides. And I'm left with log base 4 of 6x. Okay, so then how do I get rid of log base 4? Yeah, so I have to raise everything to estimate what's going to be my base. 4. Since my base was 4 with the logarithm, 4 is going to be the base when I raise all this. So basically, whatever that little subscript number is, that's going to be your base for your exponent. To the left side, we're just left with 6x, because log base 4 and 4 cancel. The right side, I have to figure out what is 4 to the 3rd power. 64. And then solving for x, divide by 6. So that would simplify. Well, it's just fraction 32 thirds. It just said solve, so I don't know. I'd rather have a fraction if you could give me a fraction. Okay. I think it's this one in square problem. Okay. So just like before, when we have 2 logarithms on one side, we want to try and combine that if we can into 1 logarithm. So if we're adding logarithms, then how do I combine them using a property? Yeah, I can multiply what's inside the logarithm. So I have x and exponent signs, so that's just going to be multiplied together with 1 logarithm now, and it's still equal 1. Okay, I can distribute this if I want to. So you could say log of x squared minus 9x. In the end, I still need to try and get rid of this logarithm. So what is the base with this log? 10. So if the base is 10, then I have to raise all this. So the base is 10 to the log base 10 of x squared minus 9x. Same thing on the right side, it's going to be 10 to the 1st power. So on the left side, just left with x squared minus 9x. The right side, 10 to the 1st power is just 10. Okay, so then how do you want to solve this quadratic? Yeah. So subtract 10 over, do the AC method, or just factor it. Yeah, so you don't have that A value, so we could just write it straight in pocket form with the numbers you figure out with C and B. So then setting them both equal to 0. Yeah. Solutions. Okay. All right, so you have deposited $1,000 in an account that pays 6.25% interest, compounded continuously. How long will it take your money to double? Okay, so we have to remember, if we're compounding continuously, what equation am I using for that? Yeah, it spells out per. So it's A equals P e to RT power. Okay, so I can now start substituting what I know. So what does $1,000 represent? The p-value. E is same. What does 6.25% interest represent? The rate, and we should rewrite it into a decimal, so it's 0.0625. We're finding how long, so we're solving for t in our case. So then what is the a value, our last case? What is the a value? Yeah, so we're doubling. Our amount is 1,000, so double of that is 2,000. So yeah. So then here I have my equation. I need to solve for the t value. So what do I want to do to both sides? Yeah. Trying to get our exponential by itself. Step 2 equals e to the 0.0625t power. And then how do I cancel the e? Yeah. So natural log to both sides. So natural log of 2 and natural log of e to 0.0625. So the right side, this cancels. I'm just left with the exponent. Natural log of 2. I'm pretty sure it's 0.693. You should check me.
Yeah.
Just start remembering numbers. Is that right? Okay. And then getting t by itself, we're dividing. So then I can figure out how many years it is. Okay. Works for me. Yeah, I'm pretty sure we're taking quiz 3.4 tomorrow. Here. We're doing section 5. Section 5 is the last section of this chapter, so test will probably be next week sometime. Yeah.
Why don't we shut down
Oh my gosh. I don't know. I don't make those big decisions. I don't get paid enough.